Let's solve this differential equation. As we can see, we have something times dx and then something else times dy, and this is equal to 0. So this looks like this is an exact equation. However, I'm not sure yet, so we have to do the check first. And remember, this is what we need to do the check, right? We have to take partial derivative. And this is how I like to remember it. If this is an exact equation, that means there's a function, and we call that to be capital F, so that this right here is the partial of f with respect to x, and this right here is the partial of f with respect to y. And this right here is telling us to do the mixed partial. If the mixed partial are the same, then it is exact because it came from the total differential of the capital F. So this is what I'm going to do. Let me just kind of go ahead and take the derivative right here with respect to y, because this was for x already, okay? So let's go ahead and do the partial with respect to y of this, which is cosine x, cosine y, plus 2x. So let's see what does this equal to. Y is the variable, x is the constant. So this is the only thing you have to look at, right? This states, so let's write it down, this is going to be cosine of x, and the derivative of cosine is negative sign. So let's put down negative in the front with the sign, and we have this y right here. And the derivative of 2x in the y world is 0, so this is what we have. And now, let's look at this. And we are going to differentiate this with respect to x. So let's put this down, partial of this right here with respect to x. Be careful here though. Be sure you account for the negative sign, okay? Because technically it's adding with this part, okay? So I'm going to write down negative parentheses sine of x, sine of y, and then plus 2y like this. Okay. We're talking about the partial with respect to x. So x is the variable and y is the constant. So you know the 2y right here is going to be to be 0. Anyways, this right here, let's write down the sine of y first, right here. And let's also bring down the negative, because I know the derivative of sine x is positive cosine x. Anyways, do the derivatives, right? You see the mixed partials are the same. That means this is exact. So now, let me just write this down. Hey, we know this is exact, so we can go through the procedure of solving this equation. And you can start off with either one. You can start off with this, or you can start off with that. Doesn't matter. Let me just begin with right here, okay? So let me write down partial of f with respect to x. We know this is this right here, which is cosine x times cosine y plus 2x. And we have to integrate both sides. And this time, we have to integrate with respect to x, okay? So that we can get the capital F, and this is going to give us, all right. In the x world, we have to integrate this. Cosine y is a constant, so let's put it down first if you would like, and integrate cosine x. We get what? We get positive sine x, right? And we have to integrate this as well. In the x world, this is going to give us plus x squared. This is it. If you want to differentiate this real quick with respect to x, you'll get this back. However, when we integrate, we have to add a constant. And in the x world, a function in terms of y is a constant. So right here, we have to add a function in terms of y. I will write that as g of y. This is considered to be the constant in the x world. And now what? Well, this is how the capital X f will look like. Well, now I'm just going to differentiate this with respect to y, so I can match with this right here. So let's do that real quick. So let's do the partial with respect to y now. You see, this is kind of like going back and forth, right? Anyways, right here you see we will have the partial of f with respect to y, and this is equal to, now differentiate this. Y is the variable, x is the constant, so let's write down sine of x. And then the derivative of cosine y is going to be negative sine y. And the derivative of x squared in the y world is 0, so this is it. And then right here we add, this is the function of y. So when we differentiate that with respect to y, we will get g prime of y. This is what we have. Now, you see, this is the partial of f with respect to y, it has to match with that. So I'm going to set this equal to, and right here, let me just distribute the negative sign into the parentheses. Okay, I think it's kind of bothering me. So let's do that. Put it down as negative sine x sine y, and then minus 2y, minus 2y. And what does this mean? Well, it tells us that this has to be the same as that, right? Because you see, this is the same as that already. So we must have g prime of y equals to negative 2y. Well, how can we solve for g of y? Let's just integrate both sides with respect to y. And on the left-hand side, you will just get g of y, and this is equal to, when you integrate this, you get negative y squared. And right here, you can put down plus c if you would like. If you just want to talk about the function part, that's okay as well. So this is it. This is just a constant c because g is just a function in terms of y. There's no x at all. Capital F involves both x and y, so that's why we have to put down g of y earlier. And right here, I would like to just write down the answer for you guys. This is the f, right? So the answer is going to be sine of x cosine of y plus x squared, and you know g of y is that, negative y squared. This is the deal. You can just write down the function part. This is the f of x, y, and you can put a constant on the right-hand side. So if you didn't want to put down plus c right here, that's fine too. But right here, I'll just say this is the constant on the right-hand side. And let me write down the sign better for you guys. And this right here is a solution. And that's it.